So, okay, guys, we are on lecture 9. Sorry, some of the lectures that last time also the recording wasn't there because of a lot of things. So today we will try to learn exactly about the areas in computer vision and how can we apply them in our field in a very comprehensive and a straightforward way. So this lecture is divided into 4 parts. I would discuss something in detail about computer vision, about deep learning. We talk about neurons. Then we talk about activation functions. And then I would do the coding in front of you for a very, very easy ML model. So let's begin. So what is computer vision? So this is an example of an elephant that is given in front of you. And you see that in this image, there are multiple bounding boxes that you see. So generally, a computer vision is it's more an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. From the perspective of engineering, it seeks to understand and automate tasks that human visual system can do. So this is a classic definition that is from some internet source. But what this definition is trying to say is that basically we want computer to have a higher understanding of digital images and video. And by doing that, if the computer is able to do an analysis of the video and images, that could help us from the engineering point of view to automate this task. Now, what all things computer is able to do? So you see on the screen now that you have an image of an elephant and a man is riding that elephant. Now, what's happening is in this image, you see that you have got all the information. So this is what computer is able to interpret, that there is a red shirt on a man, elephant is standing, there are green trees in the background, this is a leg of an elephant, and this is a shadow in the background, and so on. And this is some kind of a thing that we want for our task, that would be our microscopy images that a computer can do. Now, this is, I think we have gone through, but this is like a comprehensive presentation on what we learned last time. So this is what we see. So as a human being, what we see is 3 dogs here. And we can tell it, like, this is a dog, there are 3 dogs here, this is the background, and maybe this is the same breed. Now, this is what a human can interpret this image. Now, from here, this is what computers see. Computer is simply seeing them in terms of intensities, right? So this is now the classic computer vision applications. If you provide computer an image, what kind of information different codes can give you? And later on, we'll go on the topic, how can we apply these codes to? So I think we briefly discussed on the blackboard today, that on the whiteboard, that there are codes that can just simply tell you this is an image. If I give you an image of a cat or a dog or a car or any object that you name, you can give it a name, call it a cat. Other important field that we would that simply comes under UNet is semantic segmentation. So what does it do? The semantic segmentation, there are pixels that are classified individually. So here, all the pixels that had same characteristics here, you see by blue color. And these pixels, they all represent the sky. And then there's a pink, because they had the similar characteristics, maybe in terms of intensity, maybe in terms of feature, you call it a a grass, and here is the cat. So this is known as semantic segmentation. Now, this is a semantic segmentation, and there's a very common term that we have is known as instance segmentation. So instance segmentation is that you can tell us that, this is a one type of a dog, this is another type of a dog, and this is a cat. Similar to what I explained, this is your instance segmentation. So this is a field that we called as image segmentation. And people, they can do image segmentation as it is shown on the screen, semantic versus instance. Other thing is the task that you can do is classification and localization. So here you can see that in an image, you can exactly localize where the cat is. It is helpful for our case where we are detecting bubbles that, where the bubbles are. And then what is the other thing is object detection. In this one, it would simply detect the objects. So overall, there are 3-4 terms that I'm introducing here: classification, segmentation, classification and localization. That would simply tell you, you classify the cat, but where it is present in the image, that is classification and localization. Object detection is simply that comes under YOLO, where you are able to tell that where are the objects into the image. And then we have instance segmentation. Yes. Instance segmentation is really the state of art code. But here, the main important thing that you would keep in mind is that do you always need this code? It's an intense code. Sometimes you just want to calculate the swelling. Would you need that? How does that matter in 100 bubbles that my bubble 1 look like this, my bubble 2 look like this, bubble 3 look like this? For an application where we have, different kind of dislocations, maybe that is important, that it can tell you these dislocations, they're open loop, this dislocation is a line, and, so I made my point. Yeah. Yeah, expensive data-wise, computationally, but, and also you are getting not a number density immediately, but with object detection, you can get the number density immediately. Other task that your machine learning can do, your computer vision can do, it is in terms of landmark detection. So what is the landmark detection? In an image, what are the key points for the object in the photograph? So you see an image here. So in this one, what are the key points? So you see that they have drawn these key points. That means even if you have a blurry image of your from TEM perspective, you are able to find out the key points from the image. So here you see that it's an image of a person, and it has got a blurry image, and you can simply point out this is an eye, this is a nose, this is a lip, this is a jawline. And this thing was a ground truth information that we provided because this is applicable in both supervised and undersupervised model. And this is the final predicted result. So overall, with computer vision, we can simply do the landmark detection. That means if you have an image of a mountain on a plane, you can simply just mark the key points into that image. Now, other thing that is very commonly we do is face detection and face recognition. Now here on the image, you see that. So this is basically a difference between detection and recognition, that a lot of codes are able to detect that these are faces, but then we go to a higher end. Are you able to recognize that who is the person or what is the thing? So these are the classic examples that comes under computer vision. Now, as you progress in this field, you would be confused, and in the papers that people uses various terms. People use the term artificial intelligence, people use the term machine learning, people use the term deep learning, people use the term computer vision. And all these terms are in the papers again and again. So do you understand the difference between them at a first instance? So here, artificial intelligence is a big field that you will have where you are trying to automate your systems. Under that artificial intelligence comes two things: computer vision and machine learning. So computer vision, where I told you, it's a kind of called a subunit under artificial intelligence, is also doing a lot of other programming things than your deep learning and machine learning. All other computer vision branches, most of them, they are not involving machine learning and deep learning. But some of them, they are involving it. So then there is an overlap between them. Now, machine learning area itself has a deep learning into it. And we are somewhere here where we are merging your computer vision and deep learning. So your paper can involve all these three terms: artificial intelligence, machine learning, and deep learning. Now I would go in detail in the later slides what is the exact difference. So we are somewhere here. We are covering a branch between computer vision and deep learning. Now, here is an example. What is the difference between machine learning and deep learning? So for a moment, just forget about this entire big thing. Just remember that we are under machine learning. Under machine learning, we are doing deep learning. This is the classic thing we are going. This is important to emphasize here because you would be searching for papers. Now, here, machine learning, what does it do? Machine learning is a very simple kind of an algorithm, which you can even do it in your Excel sheet. What happens is you give an input to your algorithm, and it plots a decision tree and then gives you an output. Now, what is a decision tree like? So decision tree is something like, okay, whether will you take a car today to work or not? How is the decision taken? You would go outside, you would see, hey, how's the weather? Is it sunny? Is it cloudy? Is it rainy? Now, under the sun, you would see how much time you have. Okay, it's a sunny day, but how much time do you have? Do you have a more time? You can walk. Okay. Do you have a less time? You will take the bus. Okay. Now, other parameter would be, oh, how hungry you are. If you're hungry, maybe you just, say, I'll walk. No, I'm not hungry. I'll take the bus. Other thing is simple parameter. Oh, rain started, the bigger influence. You will simply make a decision and you will say, I'll take a bus. And you will not take a car, right? So this is simply a decision that you take every day for everything. Today in the morning, you wanted to show up in my class, but then you said to yourself many questions. What I be learning today? If you wanted to come, decision was to join this class or not. I'm learning machine learning. Okay. Am I interested? Would it help me in research? Yes. Some said no, so they didn't show up. Right? Then other parameters. What did I know anything about Python? Some said yes. No. So this is a simple kind of parameter your machine learning works on. Now, what happens with the deep learning? In the deep learning, this kind of operation is literally being held up in one neuron. And you are not literally doing these kind of decisions step by step, but instead you plug in everything into the neuron and you get it. And you get your answer. And we call it a neuron because everything is very similar to how brain operates. This is a classic example here. So this is where a deep learning is a kind of algorithm where you include neurons to it. Now, any questions here when you see this thing that, why this plot is so famous, where you're putting deep learning under machine learning? Machine learning tasks, all of them, they are in one neuron. You can simply say like that. It's more robust. It's more important. Now, this is the entire overview, what we learned. So this is how these fields are divided from artificial intelligence, where it's an automatic program, to machine learning. And machine learning is something, algorithm improve as they're exposed to more data over time. And then we are onto deep learning, where we have a lot of neurons, as I talked in the previous slide. Now we come to the task, what is deep learning? And this lecture is extremely important because you would go through that, what is exactly neuron? And this will develop a very strong thought process for all of you. So this is here, what is deep learning? Now, a deep learning, when anyone tells you, even if you Google it, there are 3 layers to it, and that you would create in your code today. So into this, we have an input layer, a hidden layer, and an output layer. Classic definition that is given everywhere on internet, that a deep learning model can be divided into these 3 layers. Now, what are these layers when you look at them? So input layer is your input that you give it to your algorithm. Then there are layers of neurons into it. And inside each neuron, there's an algorithm that we compute. Depending upon the complexity of the problem, you can choose going from this layer. Either you want 1 layer, either you want 2 layers, or you want 3 layers. So on screen, how many layers do you see right now? We see 3 layers of neuron on the screen. And these connections from which these layers are connected, they are also in our brain. And in our brain, you call them as synapse. That is why the name, it comes as a neuron. So these are your neurons are the nodes. So whenever anyone tells you, maybe in your codes, you are simply wanting the number of each neuron. And you will get these values out of the neurons. Now, any questions here? This is a classic model. It looks like anyone asks you what is a deep learning model, it simply consists of 3 layers. And layers have a lot of neurons to it. Now, how do we apply it to our problem? So there is, again, one very nice example given on the screen. This is layer 1, where you give your input. So your input would be the image. This would be your hidden layer in terms of neurons. And then would be your output layer, where you will get your final answers. Here you are getting your answers in terms of a classification, that you're able to classify images into dog, bird, and cat, versus another one, you would be giving an example, of, in your case, it would be different microstructural features. Depending upon what model you choose, if you choose a YOLO model, you will be simply getting the bounding box. If you choose your Mascar CNN model, you would be getting these names as well as masks. But all the under architecture inside the code consists of neurons, but a little bit different kind of architecture, where you will have a little bit extra features added or removed. Now, these are the classic applications of deep learning with these neurons. So the idea is to tell you that even in self-driven cars, that is very famous here in some labs in Oak Ridge are doing a lot of research on them. They use deep learning. Everything where, the case of automatic handwriting generation, we are using deep learning. In pixel restoration, we are doing deep learning, as I showed you in the examples of the images. Then all these places where you are coloring of black and white images, we are using deep learning. More interesting examples are on the right, where we are using news aggregation. We are trying to aggregate the news. We are using deep learning. Your demographic predictions, we are using deep learning. In translations, we are using deep learning. It's getting used everywhere, the same algorithm. How crazy is that? Now I come to the main topic here. What are neurons? And just, it's a 10 minutes lecture, I think, and it would just solve everything about, it will solve all your doubts. So now, what is a neuron? As I mentioned, it's a fundamental building block of deep learning. Now, fundamental building block would mean that it as you saw that last image in the deep learning, everything had nodes, and these nodes are famously called as neurons. You are giving your samples different inputs in terms of X1, X2, and X3. All over, not only internet, but many research papers, they call it as an inspiration that comes from a biological neuron. So in the biological neuron as well, we have, these places where these are dendrites, and you have these input coming from dendrites, they're coming to neurons, and then you have an output here. And one thing is synapses, where you have these connections. They are on the synapse, where it's the connection between your neuron and your input layer, and also your neuron and output layer. This connection is known as synapse. So overall, neurons, they receive one or more input signals, they perform some calculation, they send an output to neurons deeper in the neural net through a synapse. This is very straightforward. Now, here's a working example that I have presented. How to apply neuron. You can do this in your Excel sheet, and you would really amazed how easy it is. Now, on screen, you have an example. So as I told you that we are commonly using it for the classification purpose. On the screen, you have a data set. You have a data set of many people where there is an age given and there is an answer given whether the person has dementia or not. Generally, dementia is more occurring in the people at the older age. Now, this is here a data set given to you where you see that 0 and 1 are your common answers given, that people with 23 age, they have no dementia. People with 48 age, they have dementia. Some people with 53 age, they don't have dementia. But with some people, with around the same age, they have dementia. Then how do I automate this kind of data where I can give any age in our class and I can just tell that, they will have dementia or not. So this is a very easy example. So what I give you now, one parameter here, and what will a person do? He will simply try to plot this thing around X and Y axis. And he will try to fit it by a line so that there is a relationship that comes between age and dementia. So this is what is done on the screen. It's simply your equation of line. I have just plotted it. So it's this data of 0, 1 that I have versus the dementia. If I fit it linearly, I get this curve y is equals to mx plus c. This is a famous equation we know. On this, gradually we will develop the knowledge of what are weights, what are your bias here, and it would also help you in the coding. So this is here your dementia. This is the probability of the dementia. This is your age, and ultimately you are able to draw a relationship by simply this linear curve, where y is equals to mx plus c. Your m is the weight, right? Your x is your age here, and your b is your bias here. So now, if I plug in any number here, age, from the numbers that are not on the screen, for example, there is not a number on the screen as 20. Am I able to predict by a line that whether this thing will have y or not? Yes, I can. So by a simple line, I give this relationship, right? Now it will get very complex in the next slide. So please pay attention. Now I have another parameter here. Another parameter is how many times a person exercises in a month. And there's a data available in the literature that people with, with one day of exercise have no dementia. Someone, maybe there is another factor, they are young. This is just a data. People with 14 who do 14 days, that means I don't know who does it, half a month, half days per month they do exercise, they have no dementia. Some people who are here doing 17 days, they have no dementia. Whereas some people who do 8 days, they have dementia. So there is another factor on which dementia depends now, on exercise. So you have given this data, we plotted this data. Now, this is a data, this is a fit that you have, and it is just giving you an idea that now I have a probability of dementia here, which depends on your number of exercise. And I can plug in, my answers won't be very correct because this is not the best fit we know. This is just to tell you an example. But still, it will give you some numbers. Now, machine learning model will give you the right fit. When you do it by you will have a fit like this, where your relationship, where you put any number of days between 1 to 1,000, it will give you the probability of dementia. Now, I add one more parameter to it. Like this, I can have 1,000 parameters. Another parameter is a diet. Now, people who do not take a lot of omega-3, maybe they have dementia because they are taking a lot of junk food. So there's a clear relationship here. People who eat 18 days junk food, they will have dementia. Versus people who will have one junk food per month, that means they constantly pay attention, they will have zero dementia. I have a data like this. I apply it. What do I get? I get probability of dementia versus the diet in terms of number of junk food per month. Can anyone comment here on this value of B I'm getting in all these curves? What is this B value here? This is the axis, the intercept that it is making. So this term, it will keep on bothering you as I go in my next class, that what is a bias? You would keep on asking me. So this knowledge, you will directly translate to bias, weights. Here is the probabilities and here are the inputs. And here I'm just showing you one relationship of your probability versus your junk food or any parameter. That is your XI. Now what I do, you know what happens inside the neuron? The same thing. The decision thing that you were doing outside, it is happening in one neuron. So in this one, you saw that the probability of dementia, it depends on a factor called age. So out of this thing, I will have a probability out for dementia with the age I give. For example, let us take an example of Mr. Mr. say some person, say name as, oh, very good. I just cannot think of the name in this intense scientific discussion. Say that a person Paul, he has an age of, say middle-aged guy, a 40-year age guy. So his probability of having dementia, it depends on various parameters. One is his age, 40. Other is exercise. He is a decent guy. He exercises 2 times per week. That most of us do. So this is 2 times per week. He is somewhere here with 2 times per week here. That means his probability is very high, according to this curve. Now with the diet, he's crazy on junk food. He's a single guy. His wife doesn't cook, and he just eats in the canteen every day. Let's just say that. So he has his probability here for dementia. Every day he's going to McDonald's and eating those burgers. But somehow it's genetics that he's not fat. So this guy, what is his probability of having a dementia? And like this, if I take the example of our entire building, and all of us, we gave our age, we gave how much exercise and how much, and there's a data available, and we can tell what is our chances that I'll have dementia or not. These are 3 parameters. Inside the neurons, it's the same thing happening. You have all these parameters, and all these parameters, they are adding up. So my final answer that I will have a dementia depends on the value of V, of your Y1. that would come out of the probability of dementia from the age curve. Just a second, I'll just finish here. Then my Y2 probability would come from the exercise curve. Then this comes from the diet curve. That means I have these individual parameters that are influencing my final decision, a final answer. Now, what happens next inside the neurons? It's very, very interesting. So, okay, before I address your question, go ahead. You had a question. I will in the next slide. So this is a common, this is a very common example that we have. So like this, you can create various models. For example, a house prediction model in which you predict the prices of the house. They will depend upon, it's a 2-bedroom flat. You will have the entire curve like this. Whether the location is a Farragut or location is somewhere in the north part of Knoxville, not very safe. You will have a curve like this. And maybe on the square footage. And you can develop your decision, right? In your case, the same knowledge would be translated to the images, exactly the same, because we are using neurons. And all the neurons, what they do, they simply add the influence of all parameters. Mind my language here. We are adding the influence of all parameters linearly, right? So inside the neurons, this is what we are doing, adding all the probabilities linearly. Now, at the end of the class, I would ask you to translate this knowledge to the images. And you should be able to translate it, that how it is reading the images like that. It would be something that we'll do after that. Now, what is happening here? Now, this is a step 1 that is happening in neuron, and it is a classic thing that is happening. There is no change into it. You open any article, any research paper, they are using the summation, where they are just multiplying Wi xi, which is nothing, which comes the value of y1 plus y2. Now, second thing, what is happening inside a neuron is your activation function. Now, what is this activation function? Now, in the activation function, so here, these values of y1, y2, y3, it can have any values. The value necessarily can be, you will see in the next slide, I have an example. Here you see the value can be negative to very much, into 3 orders of positive. So you want to take a decision, right? Your neurons want to take the decision. And to take the decision, they convert all these values into a range from 0 to 1. And when you convert into that range, then you can make a decision. Now, how it is done? This is done by something known as activation functions. These are the things that you would change in your code when you will work with me today. And the people who will do YOLO code or UNet code, which I would encourage everyone to try giving me a code exercise, but I make it flexible to adjust for the people who have no Python experience, not make their life difficult. Otherwise, a coding exercise is what we look for. So here, this thing, what you look in your presentation here, is that I have converted everything, all the numbers that are for y between 0 and 1. And it is done by a function here, a sigmoid function, where you are just plugging in your values here. There is a Euler's number, it's some mathematical number. Basically, you are converting a big range into a range of 0 to 1. That's it. You have to just keep that thing in mind, that you are just changing the range. And your sigmoid function, it converts your input into 0 to 1, right? Now, so this is one thing that, it's very interesting that you can play with the sigmoid function. I will go back in the next slide. Now, your overall neuron looks like this right now. You have an age, you have an exercise, you have a diet, right? And I give this is an individual Excel sheet, and it is trying to calculate for a case of, some. So right now I have trained my model with a certain Excel sheet. I have trained in the manner that I know the relationship of age with the probability of dementia. I already have these numbers stored. And these ones, so any new person comes, I would know his parameter here, as I told you about Paul. So Paul came, he has a particular age, some exercise he does, he diet he does. This entire thing goes in the neurons. What happens is y1 plus y2 plus y3 adds up. And then there's a bias that would change, because in the previous slide, if I give it to Thomas, he would say that I don't want to put my line here, but I would put my line from here to here. Versus I give it to Sydney, she will say that I will put my line here. Depending upon where you put your line, you will get a different answer of bias, and you will have a different relationship of probability with the parameter. That would totally change. Not totally, but that is how you will, reach to something called regression values, right? That is a mathematical thing that we know. And finally, we are converting this into a value between 0 and 1. Now, here on the screen, there are some cases here. Now, what happened here? Here, a person with the age, with the exercise and junk food. What are we getting? We simply did that exercise, right? Because 0.023 was a number that converts my age into probability of dementia, right? And that number that came from your slope or the weight, right? So I converted this number. So this is a number that is your slope, also the weight, right? This number here, this gives me a value. Now 0.053, it multiplies with the number of days. Now this is converting it into the probability of dementia. For number of junk food, this is also converting into the probability responsible for dementia. Together, it is adding up with some B1 plus B2 plus B3, that is simply your biases here, and you get your final answer as 0.088, right? Now, if I go and I just click here, just a second. I click here and I simply give my value. So this is a sigmoid. This is a sigmoid. This is a sigmoid function here. Do you see my screen? I am sharing my screen. This is one thing I want you always make sure that I'm sharing the right screen. Right. This is the screen I'm sharing. I am sharing my entire screen. I just share my screen right now. Okay. Then I'll just go back and forth. So now here, you will just change these values. So right now, in my presentation, I had the value of 0.8 minus 0.2 and 0.4. So if I give the value of 0.2, and I execute, it is showing me a result 0.45, right? So minus 0.2 is changing into 0.45, right? Now the next value was 0.4, right? Now 0.4, the value is changing to 0.59. Now, if you continue, so everyone sees the presentation now, back, right? So my point to bring this small exercise was that you see that on your screen, you have variety of numbers, minus 0.2, 0.4, 0.128, 0.34, 0.059. If you plot these numbers, there's not a clear boundary where you will take your decision. However, if I convert these values using a function that I will apply to all of these things so that they are comparable, right? I can use any function and can bring these values and convert them to 0 and 1. And now I have this sigmoid function where my values are converted into 0 and 1. And I say that I put a point that below 0.5, we will have no dementia. Above the value 0.5, we will have dementia. It is similar to the case that where you put your threshold to take your decision. I can move this boundary line wherever I want, but here I'm just putting it in the middle. For example, for your course, I can put it at students who perform more than 80%, excellent. But students who perform more than 60%, they are good. And rest, in my mind, below 60%, they fail. However, there could be different limits, right? So wherever you put, you can change your decision based on that. But then you need to have a right scale to do that and to be able to do that. And this is a concept of activation function that we learned right now. And there are different kind of activation function in the machine learning where you can do it. So this is your dementia you can predict by this thing. Now here answer look very reasonable. The people with the lower age has no dementia. People with higher age, even he does the exercise, but age is the number one influence parameter, So different parameters will have different weightage. They will have a dementia. And here, person with less age has no dementia. He does good exercise, has no dementia. So you have these decisions, which looks very reasonable here when you look at the table. Now, what is the key takeaway message from this? This is like the building block of your machine learning models. You have in your neurons added up the probabilities of different initial parameters, that how will it influence your final answer, right? Is it easy when you try to understand this? Or you can understand it? Yeah. So this is how we are able, this is happening inside the neuron. It is simply the addition of all different parameters. Go ahead. That's a multi-dependent, yeah. So this exercise was just to give you an easy example that you're able to understand the concept as a beginner. That's what is happening. Like from this, there are different sort of models that we can build up into. But for your purposes, I think this is good. Now, this is something very interesting here. This is a dementia predictor that you can make for your thing. And generally, this is the first exercise that they do. And you can put the value here into this one, and you can do it in Excel, right? Everyone can do it in the Excel. Like you have an age, you are getting this Y out of age here for junk food. And here, you can change these values and you can predict dementia. So here, if I change the age of a person, say 64, it should be able to tell me dementia, yes. Here, if I'm changing the age of a person to 4, no. This is a model I developed for you guys yesterday night because I wanted very easy, simple explanation delivered to you, not in a very, very difficult way. As an instructor, my job is to make your life easy. Otherwise, you can, go on internet. There are too many videos available, right? That's what I've been trying to do. A lot of efforts through all I try. Now, exercise per month. He says he exercises every day. It's very good. He will have dementia. No. So something. But now, this kind of models you can create. I think anyone can create. And if you want, I can give you the link of this. This is a very easy exercise. Now we go to something called what are activation functions. Maybe what are activation function I will cover next time, but let us do 15 minutes coding exercise because that would give you an edge of what we are learning. And every day we do a small code, right? Okay. So on your screen, you see a very basic example. You see something as a plain Jupyter sheet. That's what you're seeing on your screen. Nothing else. Okay. So what I'm trying to do by this one is, this is a 10 minutes coding exercise where all these machine learning tutorials, especially in your image classification, we have a data set already there. So this data set has two folders into it. One is a folder X, where there are 60,000 handwritten digits. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 classes there. And there are the labels to it. So overall, I can provide an example here. What is my data? Zero. Zero like this. Something B was zero like this. Something B was zero like this. Everything that is provided. So one folder it just contains the handwritten. Somebody writes on two like this. Somebody looks like two like this. Somebody looks two like this. And there are 60,000 images. 60,000. Will learn to them. You tell me, exercise that I told you, after doing it, how I'm converting the your Y1 Y2. How are you learning? I will not there after 40 minutes. So 60,000 images, many ones are provided. Something else, you tell me that is you tell me that is the word. I can give it 10,000 images. Same, same kind of a thing. Translation. Right. So this is a Jupyter notebook, right? Now, handwritten digit example, very commonly available, but again, I would only touch, what is, um, so this is Give me a minute to set up. So let us start doing it. So what I'm doing is import TensorFlow. This is something you can do in your Jupyter. All the people who do your coding, someone who is, now from TensorFlow. So what I'm doing is I'm just importing libraries for some mathematical calculation, right? Or from TensorFlow, we are importing Keras, right? Now this is, I'm importing TensorFlow. Now I'm importing my matplotlib, right? Now I'm importing my NumPy. Classic libraries that we import to do calculation of the numbers. I imported it. Now what I'm doing now. Any question on these libraries, guys? Like, good. You should be able to handle this. Yeah. Now, what I want here is I would like to, upload this data set. Now, what is this data set here? I'm trying to train my model. So I'm simply uploading the data set, which is in the Keras library. So in the data set, this data set is known as MNIST data set. What is this MNIST data set? It is simply your Excel sheet, not Excel sheet, but a folder where you have 60,000 digits and their label stored. Right? So I uploaded this data. So I uploaded the training data set, which consists of 60,000. And then I have a test data sets, which I don't know what is the number they are keeping for testing, right? Now, what is the length of my X-train? This is just the length, that how many images I have. How many? 60,000. This is an MNIST data set that you Google it. It would show even, I think it should also show up in Wikipedia. It is that of a famous data set. Now, length of my test. How much? 10,000. Any questions here, guys? This is an important part of your any machine learning model. You have two folders, train, test and train. In the testing one, you have 60,000 images. Now I bring 10,000 other more people and I want to just test my model. Question? No, good. Now I want to know the shape. This is the shape. Can anyone tell me what it is? 60,000, it is a shape of my model. A lot of students were also in my seminars thoroughly, I know. So what does it tell me? 60,000, 28, 28. Tommy, answer. Yes. This is a dimension of the images 28 by 28 and there are 60,000 images. Now, X train 00. That means I'm still on the data set. I'm just opening the data set on my file. What does this number tell you? X train, and I'm opening my first image. This is my first image in terms of numbers that computer is reading it. Remember, I told you computer is reading in terms of numbers. And why everything is between 255 here, 0 to 255. Why? Very good. Excellent. 0 to 255 is the number. This is the number. That's why this is the intensity, right? And now if I change it to image, say 5, let's do it. Why not? It's showing me what? Again, because it could be a handwritten thing, 5 or 6. Now, if I do heat here, say 70,000. If we do something, 70,000, it should give me an error, right? Because error. Why is the error? Because there are 60,000 images. There are not more images. It is just opening up images in terms of number for you, right? So we go back. Which number you want me to put? Let me see, 59,000. It should open up another sheet. Computer is reading it like this, right? This is what do you think it is on the screen? 3. I just opened this image, what computer is reading in terms of pixel, just to, and there's still, I'm not machine learning anywhere. I'm just opening this image using these little commands. Match show, open it. Very easy commands here. I use plot.match show. That means just show me the image. Here I simply use, open the image. When I use this number in the square bracket, I'm just asking it to open it in the, in your numerical form in terms of your tensor, right? It's a tensor on your screen, right? So this is, I'm just asking it to give me the length. Only 3 very easy syntax I did. And it is very easy as you progress. No hi-fi syntax. People say you do not need to learn coding or Python to do machine learning. And I have gained this skill over 2 years now. I'm publishing papers. Before that, I learned coding in when I was very young. It's that easy. So now here, so now what image you want to see? Just very quickly, 59,000 images. Let's see which one is this. What number is it? 6. Now let us say what is there at 59, some number between 0 and 60,000. What image is this for? Right? So now what is a little bit important here is okay. In this one, what I did was I normalized my thing just to make it easy. These are number here. These are number, right? So by this command, I normalized each of them to some easy number. Any question here? Why I'm normalizing it? Easy to compute, less computation, smaller numbers, right? Guys, you are welcome to stop me and ask me. Now, I keep on telling everyone one thing. I hope you're not bored of listening anything. That please, in the digital image, we are flattening them. Remember, we have an image like this, 4. In your cases, you will have a void. I'm just flattening it to a one-dimensional array, right? Because I want to feed this into my neural network, right? So, any questions here what I'm doing? Yep. So what it is doing is, it's an array like this, right? It was a 28 by 28 in the past. These 28 now, there is no breadth to this tensor. Everything is in the length. Breadth is reduced to length. That means now 28 into 28 is how much, guys? What is 28 into 28? 7 something? 784. So that means these are 784 number now present in one column. That's what I'm doing, because this would be the input to my neurons. Then how these x1, x2, x3, how do I feed it? Getting connection here, what I'm trying to say. Remember, neurons has x1 to xn. This is what is going inside the neurons. Make sense? So now, let us try to know. The one thing you noticed here in the previous step, I did X-train flattened, and I call it X-train reshape. This is the name of my new. So I flatten it, and this is the name of my new. So now this is known by new name. And now I X-train flattened. Was that so? Earlier you have X-train and X-test, right? In your original data set, these were your name. Now my new names are X-train flattened and X-test flattened, right? Which is nothing but a flattened initial data, right? And now what is the shape of it? This was the number you wanted, 784. This was the number, right? So now it's a 60,784. That is where is the biggest challenge in machine learning, that you lose the feature, how to say, you lose the quality of features. Right now, the 4 is not a beautiful 4, right? It's all like merged 4. It's like if you take a photo of me, it will just give a pixel here, pixel here, pixel. It would not, it's very difficult to find out who this person is, right? So this is known as losing information. This is a very important term, is losing boundary information. Now, X-train flattened. Now, I can just know the shape if I use this thing. X-train flattened. I got an array. Now, what does an array look like? In the previous one, there was this is how you write tensors, right? One row would finish here. One row would finish here. It's a 28. It's a 28 digit long here. But now this bracket has been removed and it's a single array. Starts from here. There is no bracket. It's just one column, right? It's a computer. How will it show you? The visual is not very accurate, but you know. Any questions? So now you have converted this entire big image like this into a flattening. Make sense? Now, after flattening, my data is ready. I'm happy to go. I should be able to apply my machine learning model, right? Let's do it. I'm ready. So now I will, this is 3 lines model. Is that crazy? What is this model? I'm into Keras library. I'm asking it to do a sequential model. What is a sequential model? It is because you have input layer, your hidden layer, and your output layer. It's a sequential model. Such type of models are known as sequential. Once you are doing 2-3 type of model, you will have answer to it automatically, right? Now, with the sequential model, now this is Keras. Now, in the sequential model, I'm asking it to add a layer because there are 10 classes to it. So I'm giving it a number 10. So here is the output. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. right? These are the total classes we have. So it is I'm giving output number is 10 classes. What is my input shape? It is an array of 784. What is the activation function I'm using? I'm using a sigmoid activation function, right? What it will do? It will convert all your answers that are coming into this kind of a function so that you can easily put a threshold and decide what value it is. Now, there is a term called model.compile. There is an optimizer called Adam. Optimizer, I will go into the details next class. That optimizer is simply how you update your weights. That's an optimizer, actually, in real sense. Then we talk about a loss. These terms I will go in the next class, most important for your papers, for your learning. And then what is my performance matrix I'm calculating is accuracy, right? And then I just fitting my model. I'm fitting my model on X train and Y train because that was already an input data where my X train was connected with Y train. And how many epochs I'm giving? I'm giving it 5 epochs. That means I want my algorithm to run on my images 5 times. I will go through them again and again every time we meet, right? But this is the general meaning of these things. Any questions before I run this model? Seems pretty straightforward, right? It's running. My model is now running. And especially from the Steve's group, like Sydney will have 2 papers coming. That's really great. Right? And Julie will have 2 papers coming on machine learning. I'm still very active in this thing. I would love to have you, like already 2 papers coming in artificial intelligence applied to material science is already a big deal for you. So with this knowledge, and you can tell to the people how much time you work for the project. Not a lot. For the amount of publications per author you will get. You're welcome to help me. This is a big effort I have been taking into this department to bring AI up front. You're welcome to help me. I can reward you with a co-authorship all the time. You just need to contact me. There are various projects going on under with me. Different departments are connected right now. I did not know it would become big, but it became big. Just that when I started it, I thought I just do it because it's just fascinating. Now, what do you see on the screen, guys? Model has completed itself. What numbers are you seeing? Numbers are in terms of losses and accuracy. Remember, I only trained my model only for 5 epochs. That means I asked my algorithm to go only 5 times, right? And within that period, it is giving me an accuracy of 59%, sometimes 78%. So do you see, as epochs are passing, my accuracy is constantly increasing? For the class demonstration purpose and for the limitation of time, I gave only 5 epochs, right? If I give 1,000 epochs, I will have 99% answer, right? Now, this is this is the number given losses that I would come on the next class, but your model is trained. Now, are we ready to look at the results? That does my prediction matches with the test image that I've given? So first of all, there's one thing I will do. I will just, there's a little thingy here is, it will give you right number of the accuracies. So my accuracy here right now, I think it does some kind of average. It is 80% for this model, which is pretty good. And this is my loss. I would come on to this next step. And when you have accuracy 80%, you are ready to start as your initial thing. Now somebody has to tell me what I'm doing now. Why predict? What is it? What is this syntax here? Yep. So now I'm wanted this model. Remember this model was compiled, this model was fitted. So this model dot predict, I'm trying to now just see that this is the data X test and Y predicted would be the value of Y, right? Yeah. Yeah. This batch normalization, a lot of things. We'll get there. We'll get there. Just for 5 minutes more and we are done with, to add these things. So this was your test image that you gave, right? Let us see the result. True. My model knows that it's a true. Cool, right? Isn't it that easy? Like, it's really easy. It's just a big myth, machine learning, honestly. That's why I wanted to bring you and teach you in these 3 classes because I was confident I can do it. And if there are people proactive, we can publish papers, we can write codes, easy codes like this. It did a job, it predicted it, right? Now let us see an image. Y test 10. What was it? Is it that good? This model 0. Now predicted is 0. Wow. It says the accuracy is 80%. It should do some mistakes, right? 80%, 20% is a mistake, right? Let us just try more numbers. 100. What do you think? 6. Somebody, some Arabic guy has written, in Arabic they write like this. Okay, now 100. 6. Wow. This is great. Now tell me a number. 1,000? Some 1,000 image I take. What was the 1,000 image? It was 9. Here, what it is? 7. Mistake. Mistake. Right? Out of 5 times I tried, 1 time it did a mistake. That means error is 20% still there. And I can optimize it, right? Yeah. Yeah, here, this is the net accuracy. It's just adding up and everything. Isn't it cool what we did? There is another data set that is our fashion data set. And if you would like to try it, I would love you guys to try this data set called fashion data set, deep learning data set. This is a data set where it is already in your Jupyter, this data set. You call it as fashion MNIST. So this is a data set that is here. So let me open my notebook here. Fashion. This one, it just tells you it's an ankle boot or it's an ankle boot. It's a shirt or it's a t-shirt. So this is same thing you are matching, right? You're just matching and just telling your computer to identify this thing you will do in your void, dislocations, everything. You will give it a label that you did, Sydney. You give it a label void, and it finally, when I had the answer, it gave me a void. Remember? So, and in the previous one, you generated masks for me. In the UNET paper that was submitted this week, we had a mask on it as an output. So whatever you train your model to get it. I would just ask you to take this where I have highlighted it, data set fashion MNIST load data set, take a, I can also use this command and send you an email. If anyone can do this for me on Canvas, I love, that somebody can put it. This is a data set and you can train it, right? Once you train it, You can play with the epoch, you can play with the optimizer, and next time I will introduce you in detail what is an optimizer, what is different activation functions, what is, batch normalization. And maybe we do one YOLO. YOLO codes are working, all of them, right? I can just do YOLO in front of here. The biggest challenge is to identify why YOLO is not working on our dataset as correctly as I want it. That is the challenge I want you to dig deeper. And when you dig deeper on those data sets, there you're knowledgeable. Doing YOLO code on my data set is like a 10-minute activity. Like here. It's that straightforward. That's why I was telling you, do not worry. As you go through these classes, you will learn. And again, I take my word back. You're welcome to provide me with the codes. I would love that. Just that Python is a little bit, gap that people think and are scared of. I don't see. Right? With this, guys, thank you very much. We see you next week. Wednesday, we are meeting it on the TEM, right? Right, Tommy? It's booked, right? Great. Thank you. You enjoyed it, this class? Yeah? It was useful? I work very hard for you guys, sometimes. I sometimes think, I don't know. Right?
That was cool.
So are these free codes, YOLO, UMass cursing them, are they available for free?
Oh yeah, you just Google it, like, just write YOLO initial data set, something would come up. And you guys are volunteer. There is a publications coming up with me. You guys are welcome. This is the code that we do. Ask me over holidays. December would be the time I would be working a lot. We can develop a small project, write a quick publication, and get it through. And